Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Sharon Florentine. Welcome to today's DevOps.com webinar, How to Secure Your DevOps Pipeline with Red Hat and Synopsys. We have an awesome webinar for you today, but before we get started, I do have some housekeeping items I need to go through with you. So first, please remember that this webinar is being recorded, so if you miss any or all of it, you'll be able to go back and watch it again. We will send you an email with instructions for accessing the webinar on demand, or you can always visit us at devops.com/webinars. It will be there for you as well. At any time during the presentation, feel free to submit your questions using the Q&A tab on your console. Try and get to as many as possible we'll get to as many as we can at the end of the presentation. And finally, stick around. We're going to have some polls coming up for you, so we would love it if you could take a few seconds and give us your responses when you see those come up on your screen. And finally, at the end of the presentation, we're going to do a drawing for 4 $25 Amazon gift cards. So stick around to see if you are a winner. All right, so I'm going to hand things off to Dave Muir here and turn my camera off and my microphone and let you get right to it.
Yeah, thanks, Sharon. As you mentioned, this is going to be an awesome webinar. I want to thank Mike and Gotham for being here with me today. We're going to talk about DevOps, DevSecOps. We're going to talk about Red Hat and Synopsys and how we work together. We'll have some polls, which will be cool. We'll do some demos and just have a lot of fun. So I'm Dave Muir, Principal Solutions Architect here at Red Hat. I'm focused on our great security ISVs like Synopsys. And I'll let Mike and Gotham introduce themselves right now as well. Mike?
Cool, thanks, Dave. Mike McGuire, I'm a product marketing manager at Synopsys, and I look after our open source security tools. So Black Duck binary analysis, and also the Black Duck audit services. I joined Synopsys, it's going to be May of last year. I have a background in product marketing, and I started off as a developer. So now I'm here working on what I think are some fantastic products in a really exciting space, in a really exciting industry. So thanks everybody for having us here today, and we're real excited to be talking about this topic.
And yeah, hi everyone, this is Gotham here. I'm a solutions architect in the alliances team here at Synopsys Software Integrity Group. So my tasks are to work with great partners like Red Hat and figure out how we can help our joint customers. So with that, I'll hand it back to you, Dave, and take it away.
Thanks. Yeah, so I'm just going to cover Red Hat for less than 10 minutes. I'll hand it back over to Mike. He's going to talk about Synopsys and Black Duck, and then we'll let Gotham show us the magic with the demos. But the topic of today was securing your pipelines in DevOps and how best to do that, but with DevSecOps. And so DevSecOps in Red Hat is sort of a big thing lately. Over the last couple of years, we've been working with our customers on their journey towards DevOps and DevSecOps and ensuring security is integrated in the proper places, and that we're having those right conversations. But you might be wondering, well, why Red Hat for DevSecOps? And you'll be seeing a lot of point of view come out from Red Hat over the next couple of months about DevSecOps. But in my mind, we're in a pretty unique position being sort of the platform provider, right, with RHEL and OpenShift, and being able to work with these great partners like Synopsys to understand all the different security functions, features, capabilities that go into DevOps and containers and Kubernetes, and just have that holistic picture and understand where things should fit and how they overlap, because there's just a ton of stuff out there in terms of security, and it's really difficult to understand where to get started. So with our ecosystem, we're able to do so. And Gotham, if you go to the next slide, you can see a sort of a high-level point of view on Red Hat's position in DevSecOps. We always promote a defense in depth strategy. As I mentioned, our ecosystem, we help to implement this DevSecOps with our customers in the journey. So you can see Red Hat on the left there and partners on the right with our combined technology and our certificated, hey, that's a new word, our certified partners and their operators and their containers. We can bring those solutions, those technology solutions to our customers. But it's not just technology. Anybody who knows DevOps knows that it's a lot about culture and process. And so culture is a big thing with Red Hat and our partners, and bringing that culture change to our customers is a lot of work. And so we have some capabilities, some abilities to work with our partners around training and certification. We have some consulting services. Red Hat Innovation Labs actually has the ability to provide sort of hands-on culture change, process change with our customers where you're working with Red Hatters. So there's a lot of good stuff around helping you towards your journey to DevSecOps. One of the tools that we've used to accomplish this, in the next slide, thanks Gotham, is a framework. So Red Hat DevSecOps Framework is a tool that we've been creating over the last 2 years, and it's been vetted by industry and our partners. It consists of helping to create a taxonomy or categorization of all the security methods out there. So we started with 9 categories that you see here in red, everything from vulnerability and configuration management, which we're going to be talking a lot about today, to things like remediation and platform security, everything in between, like compliance, network controls, identity, all sorts of buzzwords around security that you might have heard, but we've done the work to categorize those and then create specific methods that sit underneath those different categories. So there's 34 methods that you can see here, things like software composition analysis, which we'll talk about, static analysis, data protection or encryption, things like forensics when security events happen. And then what we can do with those methods in the next slide is actually map those to DevOps pipeline and understand where, take this to our customers to have a conversation to start their DevSecOps journey, to say where these security methods would fit. Now, this isn't to say, hey, you have to implement every single security method at every single integration point that you see here. It's just a great guide to get the conversation started and say, you might want to think about SCA at the build automation stage, which, by the way, you should always do. It's very important. Or you might want to think about SCA while you're doing container orchestration. That's something to think about as well, because there's some integration points there. So it's a very nice tool to help that conversation started, to get a design going. And then the next step we can do with our partners is actually map where Red Hat has capabilities in these methods and where our partners have capabilities in these methods. And you can see Synopsys there has a lot of great capabilities on the left-hand side of the DevOps lifecycle around application analysis or vulnerability and configuration management. It's a very nice complement to what Red Hat does on the right-hand side with the running cluster and container orchestration. So this is basically a blueprint that we've taken to customers to get them started down creating, from a technology perspective, that DevSecOps solution. All right. Now, the foundation of that framework is Red Hat. And so I want to just talk a little bit about OpenShift and OpenShift Platform Plus, which is a relatively new offering. It's basically comprised of a couple different products. It's obviously Kubernetes at its core, certified Kubernetes. OpenShift is Kubernetes, in case you didn't know. But it's Red Hat OpenShift's added services on top of that makes the OpenShift container platform so valuable. And then OpenShift Platform Plus contains a couple more items. You can see those on the top there. One is if I look at the left there, advanced cluster management. Advanced cluster management for Kubernetes is basically an ability to manage a fleet of clusters wherever they are. You can have them on-prem or in the cloud. You can have just raw Kubernetes clusters, and what we call Rackham will manage them. And it gives you a lot of different capabilities. One of my favorites is the ability to ensure that all your clusters have, for example, Black Duck Synopsys installed on them. So you can create policies to ensure your fleet of managed clusters have everything that you want them to have. In the middle there, at the top, you can see Red Hat Advanced Cluster Security for Kubernetes. This was our recent acquisition of StackRox. This is all about runtime security and provides an added layer, defense in depth, of security controls on top of OpenShift. We believe that advanced cluster security is very complementary to what Synopsys does. Synopsys, in that framework that we looked at previously, ACS was absolutely mapped there on the Red Hat side, so it's still very complementary. And then you see Quay there as well. Quay is the container registry that Red Hat manages, where you can store your images securely. So there's a lot of features around OpenShift, especially a lot of security features. I don't have time to talk about all of them. So what I wanted to do was just do a quick top 5. This is Dave Muir's top 5 OpenShift security features. I have to say, legally, this is not Red Hat's point of view. And any resemblance to actual top TV lists is purely intentional. So let's get started with our 5th security feature in my list, and that's GitOps. And you might be saying, well, GitOps, that's about developer productivity. It absolutely is, but with that comes improved security. There's a couple things to note on the security front. One is, in the mantra of DevOps, everything as code, that actually improves your security because those configs, those policies are version controlled. And so you know who has access to what, the changes are auditable, you can manage that config drift. So that's a big security improvement. And then if you think about DORA and some of those security metrics like respond to incidents faster, when you have them in production, well, that's what GitOps helps you. That developer productivity helps you to respond faster. And so the velocity of GitOps allows you to fix those production security, those production issues quicker. All right, so that's number 5. Number 4 on the Dave Muir top security OpenShift features is Railcore OS. Railcore OS is the optimized operating system that you'll find in OpenShift. There's 2 features I just want to point out. One is transactional updates. So Red Hat Core OS, it's distributed as an image, and it always boots to the latest known good version. This is similar in principle to how container images are deployed. And then the second one is immutable management. So, certain parts of the operating system are immutable, others are not, but it allows you to ensure that the cluster is a single source of truth. And this also enables you to spawn clusters and destroy nodes pretty quickly. So that's number 4. Number 3 is SELinux. SELinux is one of my favorites. It's one of the best ways to achieve defense in depth, especially if you're thinking about zero-day vulnerabilities. You want to keep SELinux enabled, and you'll be protecting your system from runtime vulnerabilities, like a couple of them that you see here. It's basically done by enforcing a labeling system, and it's all about mandatory access controls. The important thing about SELinux with OpenShift is that it's on by default. All right, number 2 is threat detection. So threat detection is part of advanced cluster security. You can see some examples here, like shell spawned by a Java application. That could be a rogue process, malware. No resource requests or limits specified in your pods or your projects. That can lead to crypto mining, something like that, or environment variables contain secrets. So there's a lot of neat policies and threats that ACS can help you understand so that you secure your running cluster. This is obviously very complementary with Synopsys. And then my last number one feature is OpenShift Pipelines. And you're probably saying, wait a minute, OpenShift Pipelines is not a security feature. And for those who do watch top 10 lists on TV, sometimes you think about the number one top, play, and you're like, that doesn't even seem like it should be in the top 10. But actually, in my view, OpenShift Pipelines is huge for DevSecOps. It's a very critical integration point to add security into your pipeline to really get towards DevSecOps. And you can see down at the bottom right, that shield is strategically placed right next to Synopsys, because that's exactly what you want to do in terms of application analysis. You hear a lot about supply chain with DevOps, and SCA, SAST, IAST. Those are key integration points in your DevSecOps journeys to ensure that you're covering everything on the left-hand side of the pipeline, so that you don't have to worry about that on the right side. It's obviously a lot cheaper and faster to get applications out if you have this integration point in OpenShift Pipelines. All right, so that was Dave Muir's top 5 OpenShift security features. We actually have a poll for you right now before I hand it over to Mike. I'm going to click the Start Polling button, and you should be able to see it now. Do you use OpenShift Pipelines or Tecton for your CI/CD? It's pretty easy question, and the answers are either yes or no. So we will give you about 20 seconds before we close that poll. Looks like some votes are coming in. And I'll give you another about 10 seconds. All right, so far it looks like the dominant answer is no, with about 67 or so % of folks using OpenShift Pipelines. That's fine. It's a up and coming new technology, especially for your microservices or Kubernetes native applications. There's a couple more saying yes, which is good. So I'm going to go ahead and close this poll. Thanks for participating. And yeah, final results are about 38% said yes, and about 62% said no. All right, so with that, I'm going to hand it over to Mike.
Thank you, Dave. That was fantastic. Hi, everybody again. What I'm going to do is I'm really just going to go through a quick high-level walkthrough of building and securing containerized applications. And really what I want to do is further demonstrate the value of the Synopsys and Red Hat partnership and the value that the Black Duck connector within OpenShift brings to securing your whole entire pipeline from the beginning of the SDLC to the very end, which of course is really important when we're talking about a DevOps or a DevSecOps shop. So if we go to my first slide here, what we have here is obviously is an SDLC or a pipeline, and I'm sure everybody's familiar with it. You've probably seen it in a whole bunch of different formats. You've probably seen it with different phases, named different things. But I'm sure we can all agree that when we see this, we recognize it and we know what we're getting into. So at least we have a common jumping off point here. So development tends to own the left half of this, right? So we have the code, the build, and the test. I have that tag with dev. And then operations tends to own the right half, the release, deploy, and monitor. And again, depending on your organization, this might be a little bit different, but if we take the average scenario, take out the corner cases, this is probably what we're going to come up with. Obviously, responsibilities in DevOps go across the whole entire SDLC, but again, this is really the majority of the time is what we're finding. So in order to increase the velocity of software development in terms of security, the hot topic has been shifting security left. All right, so getting a little excited with me there, Gotham. One more back. Yep, thank you. So bringing security closer to the developer catches issues earlier. It reduces rework down the line, you name it. However, this can be a little bit misleading. we do want to bring as much security to the left as possible, but we don't want to do it at the cost of moving it away from other areas of the pipeline or the SDLC. So what we really want to do is we want to shift everywhere. So especially in a DevOps shop where security tends to be the responsibility of everybody, right? There's no one siloed group anymore. It's not just security team or just on the operations, it's everybody's responsibility. But again, we really want to make sure it's at every spot. So our integration with OpenShift, it gives us the ability to do that with container development and enables us to really come and put the sec or the security into DevSecOps. So what I'm going to do is I'm going to kind of step through the SDLC and show you how we bring it to every stage here. So now we'll go to the next slide, please. So starting with development, right? Let's start right at code. And of course, like I mentioned, we're building an application to be containerized. So you're going to containerize the application, which base image to start with. You go and you pull in a handful of open source packages that you're going to use. And as we are finding quite a bit recently, right, open source is extremely prevalent, it's very ubiquitous. You're going to use it as a foundation probably to build your custom code on top of to make your application unique, right? That's what you sell. So this is you building application. All this lives on your development branch or your feature branch, working area, whatever you want to call it. But since development is really the first line of defense in this situation, when you're ready to merge, you can go through and use what we have in Black Duck as a rapid scan. We call it our rapid scan. And you can evaluate dependencies against predefined policy. So it could be your security team, it could have been your team, it could be any type of risk managers, depending on your organization. They've pre-configured policy within Black Duck, legal policy, security policy. It could be stale code policy. And what rapid scan is going to do as a lightweight dependency scan, it's going to run, it's going to find your dependencies, it's going to interrogate your package managers, and it's going to run those against the policy that you have set up. It's very lightweight, it's very scalable, can do a scan in under a minute, up to 30,000 scans a day. It doesn't persist data to a bomb just to keep it lightweight and keep you agile. But the point of it is to catch and fix issues early, right? This is the very first stage, like I mentioned, the first line of defense. It can catch and fix issues early in the cycle before they're committed so that developers can go. They can see which dependencies are no-go, swap them out, or do an upgrade or a downgrade. And importantly, not be building applications on top of code that they're just going to have to go and rip out later. And of course, at the end of the day, this is really going to increase your velocity. Having to catch these issues farther down the line and come back, walk backwards and do a rework, it takes a lot of time. It has to be done sometimes, but we all know old code is foreign code, and it's just no fun for anybody. So if we move on to the next slide and address security a bit farther to the right. So depending on the results of your rapid scan, maybe everything's good to go. Maybe you're okay with what you did find. You can do some overrides. Again, depending on your policies, you might have some discrepancy. Either way, now you know what dependencies you have. So you have a good idea of whether or not you want to move forward and merge those in and start building. So here, Black Duck can identify open source that dependency analysis cannot. Now, when I say that, obviously dependency analysis, as I mentioned, is just interrogating your package managers. But there's going to be instances where you might be using languages that don't use package managers, C or C++. In that case, we can use signature or code print analysis to go through and identify open source. For a license compliance use case, there's snippet analysis, which is going to find partial snippets of code that could have been copied from Stack Exchange and pasted into an application. It still carries license obligations, so it can identify that. And of course, binary analysis. So you might be using libraries that you've never had the source code for. Your applications depend on those. You bring them in a binary format, and binary analysis can go through, check those out, and identify any open source. And of course, this is going to be made possible by integrating with your CI tools like Jenkins or Travis or Bamboo. So after you build these artifacts and container images, in our case, in our story right here, they're stored in binary repos or in container registries. And again, Black Duck is going to be able to go integrate with those repos and those registries. It knows what's coming in, it knows where to find what's stored in there, and of course knows the policy to run it against. Again, from a container perspective, our story here, Black Duck can go and scan images, container images inside the registry. And to bring binary analysis back up, this is where this really comes in. It can go and crack open those images, squash them or flatten them, and identify the open source in the layers. What makes it so much different than what else is out there is most container scanning trusts the package managers, right? It goes and interrogates the package managers, trusts what it has to say. Now, there might be an instance where a developer maybe inadvertently or maliciously say they do a delete yum, right? So they delete references to packages. You go, you interrogate the package manager and says there's nothing in there. You probably know that's not the case, but you really have no other way of finding out otherwise. So what Black Duck binary analysis does is it finds what's actually inside of your images and not what is said to be inside your images. And the more you think about it, the more of a distinction you can make between those two right there. So of course, it's going to find those policy violations and send them back so they can be addressed back in the dev stage. So that's how we're kind of taking care of the pipeline in the middle here. Now on the next slide, finally, right, we're ready to deploy our images. We have our images stored in a repo or a registry. We've got OpenShift configured to deploy pods from the registry. We've got it configured to scale to our needs, but of course, adhere to our resource limitations, for example. But we still need to be worried about, or we still need to be aware of the security, the compliance, and the code quality issues that are involved with these containers or these images that we're going to be deploying. We still need to continuously monitor them. We need to make sure that we know exactly what's going out the door, right? We need to really make sure that we're doing these final insurance scans, because again, there's security's only as secure as its or as strong as its weakest link. So we need to make sure that we're being very accurate here. So you might ask, all right, if I'm doing these scans, if I'm doing a rapid scan in the development stage, if I'm doing a build scan, if I'm scanning the artifacts in my repos or in my registries, why would I need any additional security? Well, I can provide just one example here. What about situations where components are being pulled in during development or runtime? All right, so not everything is going to go through the SDLC pipeline. Containers can come in from different locations. So for example, you might have in your YAML file, you might have it configured to be pulling in a Postgres image. It's never been built in the pipeline. It hasn't been scanned. So how do we know it's in it? How do we know that it's adhering to our policy? Now, another example is I might have pods already deployed. However, I need to go through and change my policy or my, yeah, that's right, my policy, I'm sorry. So risk tolerance has changed. There's something out there we know about. And maybe instead of blocking vulnerabilities with a CVSS score of 5, maybe I want to stop ones that have a score of 4, right? I've got pods that could be deployed in the numbers of thousands. It's really not scalable to go and pull all those down and run them through Black Duck. You're going to get really, really clogged up really quickly. So how do you go through, change your policy, and as you're getting these pods deployed, making sure that they are run against your current policy? This is where this Black Duck connector, this integration with OpenShift comes in to handy. So what happens is the Black Duck connector in OpenShift, it looks at pods being deployed. It finds unscanned or changed images. And when it finds one, it's going to go ahead and perform a scan. The BOM or the results are sent over to Black Duck. The findings are annotated on the images. And then depending on your procedures, depending on your organization or your risk tolerance, you're able to go look at those and decide what needs to be done to address them. So you can, just as important as finding these security issues and finding these liability issues is doing so in a way that really matches your speed, in a way that makes you efficient. So you can also go through and configure all different types of variables. You can configure how often to evaluate new policy, configure how often to pull in results from Black Duck, how many images to scan at a single time, and do anything you need to do to make it fit your speed, the speed of DevOps, and so forth. So I really hope this was a good, solid example of how using Black Duck and OpenShift together, and really the Synopsys and Red Hat partnership in general, can come through and support your DevOps initiatives and really take the security, the second, and put it into DevOps for you and cover you across the whole entire SDLC. So now I'm actually gonna open up a poll as well. So before we hand it off to Gotham, I'll do that. So here, and you should see it right about now. All right, and I'll do pretty much the same thing that Dave did, give you about 30 seconds or so to mull this over. Looks like I already got one response, which is great. So this is, do you have any existing SCA or software composition analysis solution? Our options are Synopsys Black Duck, non-Synopsys enterprise tool, we've got open source, and we have no or none.
We were talking about this earlier. We know that some of you might have multiple tools, but if you just want to indicate the one that you use the most, that would be ideal.
That's right. Thanks, Dave, for keeping me honest there. So we have another 10 seconds or so. We've got 18 responses. We've got quite a few open source. Actually, open source is leading the pack here. Doesn't break doesn't hurt my feelings. I don't have any Synopsys Black Duck, but maybe after this we will, right? All right, so I'm going to close this probably in another second here, and I'm sure everybody can see the results here. And with that said, I'm going to pass it off to Gotham, who's going to introduce a smarter way to build your pipeline, obviously regardless of what SCA tool you may or may not have, and of course, whether or not you're using OpenShift pipelines and so forth. So Gotham, on to you.
Thanks, Mike, Dave. This has been great so far. I can finally control my own slides, so I'll try not to mess up. Yeah, this provides a great segue, right? I mean, as we can see, the portfolios are diversified. People are using different kinds of CI/CD tools, and they are also using different kinds of security tools, right? And SCA is a component of it, yeah, for sure. But there's also other analysis, like static analysis, where your proprietary code, you're looking at, what are you actually coding? What are some of the common weaknesses that might exist in your code? Or you might actually be doing, runtime analyses, whether via a tool or just pen testing. I mean, the most of the malicious vulnerabilities are usually found using manual pen testing, and all of these are essentially, when it comes to one individual pipeline, it turns out that manually managing each of these segments of security is very tiresome. As you can imagine, you have so many tools, you have so many different procedures. What Synopsys helps you to do is maximize your return on your application security testing investments. And we do that using two primary products. The first one is intelligent orchestration, and the second one is CodeDX. So the primary purpose of intelligent orchestration is to execute the right tool at the right time at the right level. And what I mean by that is our pipelines need to be smarter. You don't need to run everything all the time to everyone. Every pipeline means something to different personas too. I mean, there might be release engineering involved, developers with additional support from CISOs or security personas. And then at the end, we need to have at the end of that pipeline, we need to have a audit trail of all the security tools that ran, all the results that were found, and housed in a central location, so you can see what is your application security profile look like. Are you decreasing risk over time, or are you increasing risk over time? Are you adding more security threat to your application? So that's the overall narration of what I have for you here. The first part of it, as I said, is intelligent orchestration. The bottom line is it will make your pipeline smarter. So the issues will be sent, the relevant issues will be sent to relevant teams. If it's a security-based issue, then it's sent to developers. It abstracts tool complexity, so you don't need to care. We try to be as vendor agnostic as possible. We don't particularly mind if you're using an open source software composition analysis tool or a third-party enterprise or our own Synopsys Black Duck. And policies can be programmatized, right? So you can write policy as code, which makes it really easy for your pipelines to be automated based on those policies. Now, we do realize that every tool has their individual policies, but there has to be a master policy that allows for you to build or break your pipelines. And the rightmost piece of it, as I said earlier, is CodeDX. It configures and stores all the vulnerabilities, correlates and aggregates them into a single profile, and gives you a very nice overview of your application threat. So bringing this all together, it will look something like this. Your AppSec or strategy, programs, and services will create a policy, set those policy up in IO, intelligent orchestration. Intelligent orchestration can orchestrate all the security tools in your pipelines. The results at the end are sent to CodeDX, and CodeDX is in constant communication with developer software tools like Jira to open issues and give you the most relevant details about your software profile. Now, there's a lot of way to configure these two tools. This is just one of the examples of how you can configure everything working together. This is sort of a framework. There's a lot of customization available when we work with intelligent orchestration and CodeDX due to their nature being vendor agnostic and flexible. With CodeDX, we also get a high-level risk reporting. So further up the chain, security personnel and CISOs can see the overall application portfolio. So with that, I have a really nice demo for all of you. So I'm going to stop sharing my slides here and go back to my demo screen and kind of bring everything that we've talked about until now: OpenShift pipelines, software composition analysis, Black Duck connector, and IO and CodeDX into one system.
You got them. While you do that, I got a question for you.
Sure, go ahead. Good.
I saw policies and policies as code. You mentioned that. I'm assuming that lends itself very nicely to GitOps.
Yeah, that definitely does. Yep.
Cool.
You can essentially with GitOps, you can essentially define resources of how it's gonna manifest itself in your operations, right? So in that sense, you can say, hey, look, I had this configuration and this policy based on these metrics. When should I be aware of these issues, and when should I just let it go, let the pipeline build and execute?
Yeah.
So I'm going to start sharing my screen. Let's see how I can work this. I'm going to start with an empty screen here and bring this page here.
That looks familiar.
So what I've done here is I've installed, the first thing that I've done in my OpenShift cluster is I've installed the pipeline operator. What it did is it installs OpenShift pipelines and 3 resources along with it. The first one is I can define my pipeline. So what kind of tools do I run in what order? And I'll show that in a minute. The second one is the tasks. Tasks are the lowest most unit to perform a task. And triggers are basically set automation tools on when to run this pipeline. So for example, the trigger that I've set for this pipeline is if anyone pushes into my repository, this pipeline will be triggered. And I'll show how that works in a second as well. So the first thing I'm going to do is I'm going to show you the pipeline and how I've set it up. The first step is pretty straightforward. This is a CI pipeline. Just keep that in mind. I mean, there are other kinds of pipeline like CD pipelines and heavy security automated pipeline. This pipeline is made to be very quick and fast for developers. So even the security scans are rapid scans, as Mike talked about. Not just SCA, but also static analysis rapid scans. So all these scans perform really quick within minutes and highly scalable. The other kinds of scans could potentially take more time in different kind of pipelines. So the first step is pretty straightforward. We clone the Git repository. We download the source code. The second step becomes more interesting. Now, this is the IO-IQ task, which means that IO looks at the GitHub repository, looks at the last commit, and figures out what were the file changes that were made. So for example, if you only made a change to a README file, I'm just using a very bland, dumb example. If the documentation teams only have changed README files, then why do you need to run security tools? There's no use for security tools if you've only changed README files, right? As opposed to, let's say you change an actual Java file or actual dependency file like POM.xml or pip or whatnot. Then all these like SCA or static analysis tools should run. So what I've done here is I've added a when expression. So if I click here, let's see if I can open this. Well, I may have to edit it. So let's just see and try to edit it. So it will show how I've configured this. It's taking a bit more than usual. There it is. So if I click on my static analysis step here, it says if my IO-IQ tasks said that I need to run, if the value says yes, if I need to run static analysis, only then will this step be run. The same goes for software composition analysis. If IO says you need to run it, it will run it. And the other steps are pretty standard. You build the software, you test it, and you push the containerized image, you package the image, and you deploy it in the OpenShift cluster. Now, I'll explain the other two tasks. IO workflow task is the piece which sends the correct information to correct people. So do you want this to send this information to Jira? Do you want us to send you a Slack notification? We compile all the results from all of these tools and figure out what's important based on your policies, right? And we only send the information that's relevant to you based on your policy into all of these systems. So you don't, because what happens with security tools is they are meant to find security issues. They're built to find security issues. So you have thousands and thousands of issues, especially in dependency analytics and linting issues in static analysis, like, oh, just change this space, remove space here, and all of these just non-issues, basically. We only want to know, like, is there an SQL injection? Is there a log injection? Or is there a package that has critical vulnerabilities, right? So we can define all of that in our policy file. And I'll show the policy file in just a second. But what IO workflow task does is, based on that policy files, what is important to you, it only sends those pieces back to you. And finally, task here is upload all your security information and result to CodeDX to aggregate and correlate and house and have an audit trail of that. So I'm gonna click cancel here, and I'll quickly show you guys how a potential manifest file or policy file configuration file looks like. So I can set my rescan threshold. Oh, let me increase the size here of this so that everyone can see properly. I can set my threshold for static analysis and SCA. Right now, I'm only using static analysis and SCA. I can also use dashed. I can also use image analysis and all of these other security analysis that are present. But just for this demonstration, I'm using SAST and SCA. I can connect a lot of tools. So right now, Slack, Jira, all of these results could be returned to SCM vendor itself. So Bitbucket, GitHub, GitHub has GitHub security panel now where third-party tools like us can push results. And here's the bill breaker criteria. What are the criteria when I need to essentially say, no, you can't proceed any further. Let's not release this particular pipeline. So for me, what is important, and you can, again, configure this, is cross-site scripting and SQL injection, right? And in SCA, this particular CVE is important to me. There's lots of ways to configure these files and say what's important to you. So here's what I can do right now. I'll show you the previous runs of all of these tools. But what I'll also do is I'll quickly try to change some stuff and actually run the pipeline. So let me clear this up. And all I'm going to do is add a small change to my POM file. And then I'll do a git status and see that I've modified the POM file. I'll also just say that it's not a major release. This is just a minor release that just my developers care about. And I will add this file. I'll commit it and say minor change to POM and push it. As soon as I push it, I can go back and I can see my pipelines that it started running because we have, push trigger configured on this pipeline. So we'll let it run. What I'm going to do until then is I'll show you the past pipelines until it kind of finished running. In this particular pipeline, I tried to release a major release, which means that it's really important. And my criteria for running all the tools are high. So both of those tools were run. And the pipelines was finished. And as you would expect, everything was successfully executed. Let me show you another example where it failed. So in this example, again, I was trying to do a major build, but I can see that workflow while sending the message actually broke the build. Because in this case, what I was, let's see, that's completed. In this case, some of the policies were violated. So you can kind of see these are the packages with the policy violations. And I've set it up to say, if you have any of these particular pieces in your workflow, then break the build. So it actually worked and broke the build. Now, if I have to see the details, what I can do, what I also see is that the build and push image step was skipped. This was skipped mainly because you don't want to push something that has policy violations. But you can actually try and see if it runs. So it still runs in your OpenShift pipeline, but it doesn't push it to your GitHub, to your Docker or Quay repository. And in the last step, what OpenShift this last step is doing is it's actually creating a container. So if I go to workloads and pod, and if I look at my insecure bank namespace, this is what's being created by the last step in the cycle. So let's see what's the status of our pipeline that I just ran.
Hey Gotham, while you're looking at that, question for you: do you see different policy configurations I think you've mentioned this at different stages, and how would IO work with that? Like, is that just another decision in the pipeline tree?
Are you asking different policies for different applications or different policies for different pipelines?
Different policies for the same application that are going from to different environments. Like development, maybe you're not doing as many scans as you are in test, right?
So that's where we have the staging. Like, what kind of release is it? Is it a minor release? Is it a major release? All of these settings can actually be run during your normal execution as well. Like, for example, I can commit this file and run the pipeline again.
Yeah, I got
you. Yeah, so it could be run, that way too. So it's still running. I'll let it run. I see that some of the tasks have failed, which is probably due to our policies and policy violation. Yeah, it seems about right. And what I've also set it up to send me Slack notifications. So if I quickly show you my Slack screen, you can see the most recent scan of this particular thing has all of these configuration problems that we just saw. And the time is just, I think, a moment ago or maybe an hour ago. Probably an hour ago. But it's going to send me another Slack notification about the same thing. So we'll let the pipeline run. I think I talked about how you can take that from here. One of the things that I wanted to mention as well is all the tools in Synopsys tool chain, whether it's our products like Black Duck or IO or CodeDX, all of them, if they are on premises, they can be deployed on an OpenShift cluster. So what I've done is I've actually gone ahead and deployed my CodeDX instance in OpenShift. So if I show my CodeDX here, I go to my network and see routes. You can see my CodeDX instance running here. And I just need to give a correct URL. And I would quickly like to show you how vulnerabilities actually exist and live in CodeDX. So the first view that we get of this application is the dashboard. So I can really see from a high level, what kind of analysis am I doing? Is it static analysis? All of these are demo data. Please keep in mind these are not real data. It takes a little bit of while for CodeDX to actually populate these screens. So I'm just using a demonstration here. I can see code metrics, how many lines of code, what is my analysis frequency, like how many times a week am I running my analyses, what is my creative versus resolve, am I creating more issues than am I resolving, those kind of things. What kind of top issues that am I finding? Is it cross-site request forgery, SQL injections? What are those issues? And then this is for high-level statuses for CISOs and application stakeholders. But I can also deep dive into a low-level information sequence where I can see what are the exact lines of code where some of these issues persist. Not only CodeDX aggregates, which means that collect information from all of the tools, it also correlates them. So which means that if one tool finds out the same issue, another tool finds out the same issues, it will consider both those two issues to be the same. One step ahead of what it can do is it can do hybrid correlation as well, which means that if you have a static analysis tool like Coverity or Polaris, and if you have an interactive analysis or dynamic analysis tool like Seeker or our Dash tool or pen testing tool, it can merge those results too. So the first example I see here is actually of those two merged. So I can see Seeker and Coverity both pointed to the same SQL injection. If I click into it, I can find out the exact lines of code. That's where the issue persists. I can get data from the tool itself. So if there's some data flow map which Coverity gives us, if that information is available, I can get that information from those tools as well. So that's a very brief. There's a lot of features both in IO and CodeDX. I could only show you guys like how a pipeline could potentially run and what I find something that's to be cool. But going back to the OpenShift pipeline, let me see my pipeline here. See how it ran. Oh. See, pipeline runs. It failed. It performed all the scans that it needed to perform, and as expected, like the workflow engine basically said, I'm not sure why I'm not seeing the logs, but it should just say that it doesn't meet your policy status because you have all of these components with policy violations, and that's why it's breaking the build. So that's it. I'm gonna leave 5 minutes for Q&A. I'll stop sharing my screen and get back to Q&A.
Awesome. All right, so we'll actually have about 3 minutes for Q&A. I need those last couple minutes for my housekeeping and to give away our Amazon gift cards. But let's see what we've got. We did have a lot of great questions come in from the audience. So rest assured, if we don't get to your question, though, we're going to round all these up and send them over. And Gautam, Mike, and Dave will be able to follow up with you offline. So let's see. So here's a fairly general one. If the code doesn't change after deployment, why would we need SCA or OSS scanning during runtime?
Sure. I think, Gautam, yeah, please do come at the end here to fill in anything
I can add if you want.
Sure, go ahead.
So essentially, yes, you're right. Code doesn't change after deployment, but your policies and your security posture might, right? You might think that, okay, now this package, we have a new vulnerability. There's a new vulnerability of this package, and it doesn't fit your policies and your black duck. You want to know what are the running containers and running applications that I have that has those packages, right? Because you eventually might be a victim of that attack, or just have that policy be violated. The other piece of it is, as Mike actually put this point forward, is not everything goes through your pipelines. Not everything that you produce will go through your pipelines. Like, there are third-party tools and pieces, and the most common example that Mike gave was like of Postgres. What if you're using a very old version of Postgres that you haven't scanned in your pipeline through your OSS open source tools or whatever tools you're using to scan them? You still want to be aware of, like, what are the security risks that container that I'm getting from Bitnami or Postgres can. And remember, database is the most important layer. Like, that's where your customer data lives. So.
Yeah. All right, cool. Thank you. Well, again, folks, if we did not get to your question just now, we're going to send all those over to Dave, Mike, and Gautam, and they will be able to follow up with you offline. But for now, I need to remind you that the session has been recorded. So if you missed any or all of it, or just want to watch it again, we will send you an email with instructions for how to do that. Please keep an eye on your inbox for that. And our 4 Amazon gift card winners for today are Paul P., Julia R., Carlos M., and Shakti S. Congratulations to all of you. We're going to send you a separate email with instructions for claiming your gift card. So keep an eye out for that. And if you do not see it, please check your spam folders. Thank you all so much. First, for the great presentations and the demos that we saw. And thank you to the audience for joining us today and for sending in all these great questions. We really appreciate your time, and we hope to see you again soon. With that, I am Sharon Florentine, signing off.